Hi friends, today we are going to talk about a new concept, that is electric field. For the sake of Tamil medium students, electric field in Tamil means minpulam. Suppose I have a charge, positive charge, let us say capital Q, and at a distance r, let me assume that there is a small test charge which is also positive. So this is a very small charge, so it's reckoned to be a test charge. Now, as per the Coulomb's inverse square law, the force acting between these two charges can be stated as Q naught by R square multiplied by the Coulomb's constant K. Now this is very much familiar and we have discussed enough about Coulomb's law in the last lecture. Now let us say that this particular point is P. Now let us define the electric field at this particular point P. The electric field at this particular point P is given by the relationship, the force, the ratio of the force separated by the test charge Q naught. The force experienced by the test charge and divided by this test charge would be the electric field. So electric field is very much similar to the gravitational field. The gravitational field is given by the formula force separated by mass. Similarly, electric field is given by the formula force separated by charge. Imagine you have a bar magnet. So let us say this is a bar magnet. This is North Pole and South Pole. So in the space or surrounding the bar magnet, you will have the influence of the magnet, and that is called the magnetic field. Similarly, in the space surrounding a charge, there is this particular influence of this charge, and that is quantitatively called as the electric field. Now let's play with these equations. Now let's calculate the electric field at P. So we already know the value for F. So F is given by Q naught divided by R square, and this will be Q naught multiplied by the Coulomb's constant. So the Q naught vanishes and you will be getting K Q by R square. Now electric field is a vector, and similarly the force is also a vector. So if these two charges were positive, now there will be a repulsion, and as a result of the repulsion, the force will be along this particular direction because of the repulsion of the two charges. Similarly, the direction of the unit vector r cap will be along this particular direction. So if you add vector symbols, then this becomes a vector. So r cap is included here. Similarly, the electric field at P will be a vector, which is given by the formula KQ over R square into R cap, which is the unit vector. So this is one of the important relationships in electromagnetic theory. We have already seen this particular relationship, that is F is equal to K Q1 Q2 by R square into R cap. Similarly, this is another important relation which talks about the electric field. So now let's consider this situation a little bit detailed. Suppose you have a positive charge, let us say, which is +3. So this can be in coulombs or microcoulombs or nanocoulombs, it doesn't matter. They are all relative. Now the field lines, the electric field lines, which are used to describe the electric field, and this particular concept was proposed by Benjamin Franklin once again. So he used this term electric lines of force. So generally we represent the electric field lines or the electric lines of force away from the positive charge and towards the negative charge. So this will be the pattern of the electric field lines which are coming out of this charge plus 3. So you can see that as we go away from a charge, the lines diminish in terms of number, which means that the influence of the electric field fades away with the distance, because the electric field is always, as you can see in the formula, is inversely proportional to 1 by r square. So it decreases as 1 by r square with the distance. Suppose you have another charge here which is minus 1. So you can understand that the electric lines of force will be directed towards this particular charge minus 1. Similarly, you get a lot of lines when you are very close to the charge, but however, if you are away from this particular charge, the number of lines decrease, which means that the influence of the electric field decreases with the distance. Suppose, let us say, so for the benefit of Tamil medium students, this particular this thing is called Thanitha Minnootam. Suppose, let's say that this particular charge plus 3 is attracted towards another particular charge which is minus 1. So let us assume that they are close to each other. So the electric lines of force will be something like this. It will be directed away from plus 3 and it will be converging on minus 1. Suppose if you keep a test charge, let us say Q0, very close to minus 1, then what will happen in the sense, this particular minus 1 will attract this Q0. So the attraction will be directed along this particular direction. However, if you drag this test charge and keep it over here, let us say, then the attraction will be along this particular direction, because the magnitude of plus 3 is greater than minus 1. When you are closer to minus 1, you can be certain that the minus 1 has got some sort of an influence. The plus 3 also will try to repel this particular charge Q0, but however the attraction of minus 1 overweighs the repulsion of this particular charge plus 3. However, if you drag this particular charge and keep it over here or here, this will always feel the force of repulsion as if a net charge of plus 2 is there. So you can always summarize these two charges and you can make it as a net charge of plus 2 Q or plus 2 coulombs or whatever it is. Now there is a particular point in between where the electric field will be 0. Why? Because here the direction will be along this direction, is along this direction. Here the direction is along this direction. So there will be a particular point where this flipping of the direction would take over, and that particular point the electric field is 0. So you can think about it. Now if you think in terms of the relative strength, you have to understand that electric field is a mighty force compared to the gravitational field. Now electric field or the electrostatic force of attraction or repulsion is greater than the gravitational force of attraction by an order of 10 to the power 40 times. So it is a very strong force compared to the gravitational force of attraction. So to summarize whatever we have explained today, electric field is nothing but a force separated by a charge, and quantitatively it is given by K Q by R square R cap, as this is a vector. In the next class we will talk about dipoles.